10:39 on the night of October 9, 1963, one of the tallest dams in the world faced a force no spillway had been designed to release. The 262-meter concrete arch did not split open. It remained standing, but behind it, an estimated 270 million cubic meters of Mount Toc accelerated into the reservoir. The impact drove roughly 50 million cubic meters of water over the crest and into the narrow valley below. Longarone and neighboring settlements were destroyed. The official death toll is 1,917. This is often called the Vajont Dam disaster, but the dam did not collapse. The strongest component survived inside a system that failed around it. The dam closed a steep alpine gorge in northern Italy. Its thin double-curved wall transferred water pressure into solid rock on both sides, and structurally it was an extraordinary achievement. The governing hazard, however, was not only the wall, it was the mountain beside it. As the reservoir filled, the northern face of Mount Toc began to move. On November 4, 1960, a slide of roughly 700,000 cubic meters entered the lake. A much larger, unstable mass was then mapped above the water. Operators lowered the reservoir, built a bypass tunnel, and installed survey markers. The warning was visible. The project did not ignore the slope. It made a more dangerous assumption that the slope could be managed. Measurements seemed to show a relationship. Raise the water and the hillside moved faster. Lower it and the movement slowed. That pattern encouraged a control strategy: use the reservoir level like a brake, guide the mountain toward a slower slide, and keep the lake low enough to contain the resulting wave. Engineers also built a scale model of the reservoir, but the tested scenario involved a landslide far smaller and slower than the mass already identified on Mount Toc. Around 700 meters above sea level came to be treated as a protective operating level. The number looked precise. Its safety depended entirely on the assumed size and speed of the slide. Those assumptions were wrong. During the third filling in 1963, the reservoir reached about 710 meters above sea level. By late August, Mount Toc was accelerating again. In late September, operators began lowering the water toward the level they believed would limit the wave. The mountain did not stop. Survey markers that had moved by millimeters per day climbed through centimeters per day. Some exceeded 20 centimeters per day before failure. Rainfall and groundwater added pressure inside a slope already shaped by an ancient landslide and weak clay-bearing layers. The control input was moving downward. The hazard was accelerating upward. By October 9th, a major slide was expected. What remained underestimated was how fast it would move and what that speed would do to the water. At 10:39, the mountainside released. A block almost 2 kilometers across moved at roughly 90 to 110 kilometers per hour. Within about 45 seconds, the mass had crossed into the reservoir and come to rest against the opposite side. Water surged in several directions. One wave climbed the opposite slope. Another struck settlements around the lake. A third, carrying an estimated 50 million cubic meters, crossed the dam and plunged through the gorge toward Longarone. The concrete arch absorbed the event and remained. Below it, the wave erased streets, buildings, and families before most people could understand what they were hearing. Of the 1,917 victims recorded by Italian civil protection, 400 were never found. The dam still stands. The criminal proceedings that followed ran from 1963 to 1971 and assembled engineering reports, models, measurements, photographs, and testimony into a record of human responsibility. Vajont changed the question engineers ask about large systems. A component can perform exactly as designed, and the surrounding system can still be catastrophic. Monitoring is not protection if the data cannot force a different decision. A safe limit is not safe when the scenario behind it is too small, and a structure cannot be separated from the ground, water, institutions, and communities that define its real boundary conditions. At Vajont, the project kept treating the reservoir as the control variable. The mountain had become the system. The dam held. The human barrier did not. Fault Cascade. One fault, every consequence.